Hey there, and welcome back to How'd You Get That? Today we are tackling this problem. Given two circles that are centered each on the arcsine function and the arccosine function, such that the endpoints of each of those functions lies on a diameter of their respective circle, what is the intersection point of these two circles? We'll need to use the information that x minus h squared plus y minus k squared is equal to r squared, where this is the definition of a circle with a radius of r and a center point of h comma k. All right, so let's just jump right into it. So if we look at these two functions, their endpoints must lie on diameters of two different circles, one here and one here. Now, in order to find the intersection point of these two circles, we need to basically compare the two circles together or set them equal to each other. We'll do that in a minute. First of all, we need to find the center point of each circle and the radius of each circle. To find the center point, let's use the information that each of the endpoints of these functions lies on the diameter of one of the circles. To find the centers of the circles, we basically need to find the midpoint between the endpoints of each of these inverse trig functions, because the endpoints of the inverse trig functions lie on the diameter. Therefore, the endpoints are also collinear with the center of the circle. Now, in order to do this, we just need to know what the coordinates of the endpoints of these trig functions are. So for instance, for arcsine, we know its endpoints are at -1, negative pi over 2, and 1, pi over 2. To find the center point of those two coordinate points, we basically take the average of the x and the average of the y coordinates. So for the x, we have -1 plus 1 divided by 2, that's just 0. And for the y, we have negative pi over 2 plus pi over 2, which is also 0. So the center of this circle is just 0, 0. Nice and easy. So let's try to find the center of the arccosine circle. We know that its endpoints are at -1, pi and at 1, 0. If we do the same sort of averaging of the x coordinate and the y coordinates, we get that the center of this circle and the midpoint of the endpoints should be at 0, pi over 2. Okay, so h, k for the arcsine circle is 0, 0, and h, k for the arccosine circle is 0, pi over 2. Let's try to find the radii of both of these circles. So to find the radius of the arcsine circle, all we need to do is take the distance from the center of the circle to any point on its edge. One of those points could be the endpoint of the arcsine function. So for instance, if I take the distance from 0, 0 out to 1, pi over 2, I can use the Pythagorean theorem to now find the hypotenuse of this triangle that I've drawn out here. That turns out to be, after a little bit of math, we find that it is equal to 1 plus pi squared over 4. That's actually r squared, not the radius itself, but r squared. But that's okay, we actually only need to know what r squared is to input it into our circle equation. We don't need to find r explicitly. If we do the same thing for the arccosine function, we find that its radius is exactly the same. The radius squared is equal to 1 plus pi squared over 4. All right, so now we can write two circle equations that look like this. X squared plus y squared is equal to 1 plus pi squared over 4 for the arcsine circle. And for the arccosine circle, we have x squared plus y minus pi over 2 squared is equal to 1 plus pi squared over 4. Now, we can set these equal to each other, or we can use a systems of equations technique by doing elimination through subtraction. If we do that, we eliminate both the radius part of this and the x squared part of this, and we're just left with the function in terms of y. So we have y squared minus y minus pi over 2 squared is equal to 0. That means that we now need to expand the right-hand side of this equation. We need to FOIL the stuff in parentheses. When we do that, we get this result. Now I'm going to combine like terms, and we're going to now get this result. As you can see, the y squared terms just cancel out, and I'm left with pi y minus pi squared over 4 is equal to 0. Now that's pretty straightforward. That's just a linear equation in y. So solving for y, I get that y is equal to pi over 4. Now we can take this y coordinate and plug it back into either of our circle equations. Since the arcsine circle equation is simpler, let's use that one. So we have x squared plus pi over 4 squared is equal to 1 plus pi squared over 4. Now we just need to solve for x. We can subtract pi squared over 16 from both sides, and if we make everything into 16ths as its common denominator, we get this result for x squared. Now all we need to do is take the square root of both sides. Remember, we need to take the plus or minus of the square root when we take the square root of both sides. That means now that x is equal to plus or minus the square root of 3 pi squared plus 16 over 4. That's a bit of a mouthful and not the most elegant answer in the world, though it is the exact solution here. But instead, I'm going to reduce this down to its decimal approximation, which would be plus or minus 1.688. Or thereabouts. So we can see we have 2 points of intersection for these two circles. Negative 1.688 comma pi over 4 and 1.688 comma pi over 4. If you have any questions, leave them in the comments below, along with any suggestions you might have for future episodes of How'd You Get That? Hit that like button, subscribe, and hit that notification bell so you never miss another math, physics, or problem-solving tutorial. Thanks so much for watching, and I'll see ya in the next problem.